we have seen before that 3 is the barycenter of 1 and 2 weighted by their respective mass in a diagram that would have as axis X, the moisture content, and H, the specific enthalpy. Now we have also seen that the specific enthalpy can be approximated as being a linear function of the temperature and the moisture content. And this can be seen clearly on the Carrier diagram because isoenthalpy curves are straight lines and evenly spaced in the diagram. So that would mean directly that 3 is also a barycenter of 1 and 2 in a diagram that would have as axis the moisture content X and temperature that I have written theta. So in that case, let's look at the Carrier diagram. So with temperature at x-axis and moisture content as y-axis. So this is the saturation line. For point 1, we know that the temperature is 25 degrees. So we look at 25 degrees and we know that the state of system 1 is somewhere there. We know also that the moisture content is 60%. The relative humidity is 60%, so you can look at the relative humidity of 60% and the intersection there is the state of 1. For system 2, we know that the temperature is 10 degrees, so you look at 10 degrees. And we know that the air is saturated, so it means that the relative humidity is 100%. So there you have number 2, the state of number 2. If 3 is a barycenter of 1 and 2 in such a diagram, it would for sure be located in the segment between 1 and 2. So you can draw the segment between 1 and 2, and we know that the mass of system 1 is 1 kilogram of dry air, and the mass of system 2 is 2 kilograms of dry air. So this means that we have twice more of system 2 than of system 1. So the state the point that would describe the state of system 3 would be twice closer to 2 than to 1. So you can divide this segment into 3 sections, and that's the state of system 3. So thus you can simply find graphically what is the state of the mixture, and then you can just read all the things you want. So you can read there the moisture content of point number 3 here. You can see the temperature of point number 3, and there you can read the specific enthalpy of point number 3.